Good day and welcome to our video. In this presentation, we will learn about what is standard enthalpy of formation and steps to get the enthalpy of reaction. Let's start. The standard enthalpy of formation is a measure of the energy released or consumed when 1 mole of a substance is created under standard conditions from its pure elements. These values are especially useful for computing or predicting enthalpy changes for chemical reactions that are impractical or dangerous to carry out, or for processes for which it is difficult to make measurements. The symbol of the standard enthalpy of formation is delta HF, in which this stands for the following. Delta, a change in enthalpy. Degree. A degree signifies that it's a standard enthalpy change. F. The F indicates that the substance is formed from its elements. And now, let's start with the steps. The first step is to write the balanced chemical equation. Then, we need to know the formula. The formula of the enthalpy of reaction is equal to the sum of the enthalpies of formation of the products minus the sum of the enthalpies of formation of the reactants. Next, look up for the enthalpy of formation values for the following products and reactants and substitute or plug them to the equation. Take note that you must also need to specify the state of your products and reactants to get the exact enthalpy of formation value. And now, you can proceed to calculate the equation. Now, let's try with our first problem. Calculate the enthalpy change of the following reaction. Ammonia plus hydrochloric acid goes to ammonium chloride. So in our first step, we need to make sure it is balanced first. And after we note it's balanced already, we can now proceed. Now, we need to start off with the formula, which is that the enthalpy of reaction is equal to the sum of the enthalpies of formation of the products minus the sum of the enthalpies of formation of the reactant. Provided here is the enthalpy of formation values, which we will be plugging on our equation. For the product side, we have 1 mole of ammonium chloride and the enthalpy of formation values of ammonium chloride, which is negative 314.4. And on the reactant side, we have 1 mole of ammonia multiplied by the enthalpy of formation value for ammonia, which is negative 46.2, plus 1 mole of HCl gas multiplied to its enthalpy of formation value, which is negative 92.3. Now that we plotted all the values onto the equation, we can now simplify each side. Now here, you have negative 314.4 on the product side minus the summation of the reactants, which is negative 138.5. And now, we have the enthalpy of reaction of this chemical equation, which is negative 175.9 kilojoules per mole.
And now, let's try again with another problem using the same steps. Calculate the enthalpy change of the following reaction. Propane is burning in oxygen gas to give carbon dioxide and water. So here's the equation that we will use. The change in enthalpy equals the sum of the standard enthalpy change of formation of the products minus the sum of the enthalpy of formation of the reactants. With this, we need the standard enthalpy change of formation values. So for propane, it's negative 105 kilojoules per mole. Oxygen is 0 because it is an element. Carbon dioxide is negative 394 kilojoules per mole, and water is negative 286 kilojoules per mole. But because we have 3 moles carbon dioxide, we multiply the value in the brackets by 3 and same for the water. We have 4 moles of water, so we multiply everything in these brackets by 4. Now, when you add them all together, you get negative 2,326 minus negative 105, and the total we get is negative 2,221 kilojoules per mole. So that's the change in enthalpy of reaction using standard enthalpy of formation values. And that's the end of this video on how to get the change in enthalpy of reaction. Thank you for watching.